Hello, my name is Genesis Monre Rivera. My student ID is 132567. I am enrolled in Science 1441, Section 80 at the Polytechnic University of Puerto Rico. In this video, I will present Laboratory 3, Electric Fields and Equipotential, where I use the PHET charges and fields simulation to analyze electric fields and equipotential lines for different charge configurations. For this experiment, I use a computer with internet access, the PHET charges and fields simulation, and Excel to organize my data and generate graphs. The purpose of this experiment was to explore how electric fields and equipotential lines behave under different charge configurations. First, I carried out practice activities using case 1 and case 2 in order to become familiar with the behavior of electric field vectors and equipotential lines under simpler configuration. In case 3, I focused on the quantitative analysis of the systems, applying the required equations and calculations to obtain distance and voltage values, complete the data table, and generate the corresponding voltage versus distance graphs for the two parallel plates configuration. In case 1, I created a system with one positive and one negative point charge by stacking individual charges at the same location. I displayed the electric field vectors and equipotential lines to observe their shape and direction. This configuration shows radial electric field patterns and circular equipotential lines around each charge. In case 2, I formed a positive plate using multiple charges arranged vertically and placed a negative point charge at a fixed distance from it. I again displayed the electric field vectors and equipotential lines. This configuration produced distorted equipotential lines due to the interaction between the extend plate and the point charge. In case 3, I construct two parallel plates, a positive plate on the left and a negative plate on the right, each formed by stacking multiple charges. After displaying the electric field vectors and equipotential lines, I performed quantitative measurements. I measured voltage values at different distances along two paths located between the plates, one slightly above the center line, called middle up, and one slightly below it, called middle down. These values were recorded and later organized into tables and graphs of voltage versus distance. The voltage versus distance graphs for both measurement lines produce linear relationships with slopes of approx negative 368 volts per meter for the middle up line and for the middle up line, and negative 341 volts per meter for the middle down line, both with an R-squared value of 1. This indicates a very strong linear correlation and confirms that the electric field between the plates is approximately uniform. The small difference between the two slopes can be explained by measurement uncertainty related to sensor placement and grid resolution. By averaging, both values are representative magnitudes of the electric field between the plates was obtained. Overall, this experiment helped me visually and understand the relationship between electric potential, distance, and electric field, and how different charge configurations influence field behavior. This laboratory reinforced both the conceptual and experimental understanding of electric fields and equipotential lines. Thank you for watching.